In the last video, we discussed about types of errors. In this video, we are going to discuss about combination of errors. In types of errors, we discussed about absolute error, mean absolute error, relative or fractional error, and percentage error. Now let's start with combination of errors. In combination of errors, we majorly have three subtopics: combination of errors in addition and subtraction, combination of errors in multiplication and division, combination of errors in powers of quantities. Let's start with in addition and subtraction. Combination of errors in addition and subtraction. Let's take two quantities A and B. When you add two quantities A and B, and when you subtract two quantities A and B, how will their errors combine? When you add two quantities A and B, then their absolute errors also added. When you subtract two quantities A and B, but their errors will added, irrespective of addition or subtraction. Irrespective of addition or subtraction, errors will added. Error in delta Z equals to delta A plus delta B. Remember that. When you add two quantities or when you subtract two quantities, but their errors will added, then Z becomes Z plus delta Z. Here, Z becomes Z plus delta Z. Now come to multiplication and addition. When you multiply two quantities A and B, and when you divide two quantities A and B, in multiplication and division, fractional errors, relative errors of the two quantities will added. In addition and subtraction, in multiplication and division, fractional errors are added. Fractional error in A is delta A by A plus delta B by B. Similarly, in division also, fractional errors are added. Delta Z by Z equals to delta A by A plus delta B by B. That's the difference between addition and subtraction, multiplication and division. In addition and subtraction, absolute errors are added. Remember, these are absolute errors. In addition and subtraction, absolute errors are added. In multiplication and division, fractional errors are added. Delta A by A is fractional error, delta B by B is fractional error. Similarly, here also. Remember this. Once again, in addition and subtraction, absolute errors are added. In multiplication and division, fractional errors are added. When the quantities have powers like Z equals to A square B cube by C power 4. How will error in A, this delta A is error in A, delta B is error in B, delta C is error in C. How will these errors combine in Z? Fractional error in Z equals to, this power become multiple of fractional error of A. Here power of A is 2, right? 2 become multiple of fractional error of A. Delta A by A is fractional error of A plus this 3 is power of B. 3 become multiple of fractional error of B, that is delta B by B. Here power of C is 4. 4 become multiple of fractional error of C, delta C by C. Whatever it is, errors always add up. Either in addition, subtraction, multiplication or division or in powers, errors always add up. Errors never go subtraction. So error always add up, but in powers, the powers become multiple of that fractional error. 3 become multiple. See, power of B is 3. Then 3 become multiple of fractional error of B. Remember those. Let's see a few examples on this. Look at this example. R1 equals to 100 plus or minus 3 ohms. R2 is this much. Find the equal resistance in series. In series combination, equal resistance R equals to R1 plus R2. That is equals to, value of R1 is 100 plus value of R2 is 150. 100 plus 150 becomes 250 ohms. That is R. But we need delta R. But delta R is how much? Find delta R. Look, this is addition. R is addition of R1 and R2, right? Then delta R becomes delta R1 plus delta R2. Delta R1 is 3 ohms plus delta R2 is 2 ohms. Becomes 5 ohms. This is delta R. Then the value of R equals to R plus or minus delta r. Value of r becomes r plus or minus delta r, that is r is 250 plus or minus delta r is 5. Total 250 plus or minus 250 plus or minus 5 ohms. That's the equal resistance with error limit. Let's see another example. T1 is given as 20 plus or minus 0.5 degrees centigrade. T2 is given as 50 plus or minus 0.5 degrees centigrade. He asked you to find temperature difference T. Temperature difference means T2 minus T1, right? T2 minus T1 is how much? T2 is 50, T1 is 20. 20 minus 50 minus 20 is 30 degrees centigrade. This value of T, but I want delta T, error in T. Here T1 and T2 are subtracting each other, but their errors will add up. That is delta T2 plus delta T1. Delta T2 is 0.5 plus delta T1 is 0.5. Total 1 degree centigrade. This is delta T. Then the final value of T becomes T plus or minus delta T. That is 30 plus or minus 1 degree centigrade. This is the value of T. Remember, when two quantities subtracting each other, but their errors will add up each other. Let's see third example. Length of a rectangle is given like this, breadth is given like this. He asks you to find the area of that rectangle. What is the formula of area of that rectangle? Length into breadth. Here the two quantities are multiplying. When two quantities are multiplying, their fractional errors will add up, not absolute errors. First find area. Let's find area first. Length is 5.7 times breadth is 3.4 centimeter into centimeter square. 5.7 times 3.4 is 19.4 centimeter square. Now we need to find delta A. We know the formula that delta A by A equals to delta L by L plus delta B by B. From this we need to find delta A. Send this A to that side, it will become delta A equals to delta L by L plus delta B by B multiplied by A. Now substitute the values into this equation. Delta A equals to delta L is 0.1 divided by L is 5.7 plus delta B is 3.4 divided by delta B is 0.2 multiplied with A is 19.4 that we calculated. So if you simplify this equation, finally you will get 1.5 centimeter square. Delta A is 1.5 centimeter square. Now we know the value of A and delta A. Then the measurement will be A plus delta A, which is equals to 19.4 plus 1.5 plus or minus 1.5 centimeter square. This is the value of A. Okay. Now let's see another example on division. Voltage is given like this, current is given like this. He asks you to find resistance. What is the formula of resistance? R equals to V by I, right? Voltage by current. Find the value of R from this equation. V is 100 volts divided by I is 10 amperes. 100 by 10 becomes 100 by 10 gives 10 ohms. Value of R is 10 ohms. Now we need to find delta R. How can you find delta R? We know the equation delta R by R equals to fractional error of voltage plus fractional error of current, that is delta V by V plus delta I by I. We need delta R only, right? Send this R that side. Delta R equals to delta V by V plus delta I by I multiplied by R. Now substitute the values. Delta R equals to delta V is 5 volts, V is 100 volts plus delta I is 0.2 volts, I is 10 volts multiplied by R is 10 ohms. If you simplify this equation, you will get 0.7 ohms. delta R is 0.7 ohms. We know R and delta R, then the measurement R becomes 10 plus or minus 0.7 ohms.